make it harder. So we can do sine squared. What about sine cubed?
Sine squared times sin.
Okay, how does that help us?
You can integrate them individually.
You're right, that's exactly what I want to do. How does that help me?
What do you mean, how does that help you?
Gets bigger.
I still can't integrate that.
Can't integrate sine
Because you're sine squared.
I can. What do you want me to do?
Top left.
I'll do this.
Yeah.
That's not going to help. Let me show you what happens. By itself, that's not going to help you because that becomes half. Sine squared is 1 minus cos 2x sine x. Don't do this. Because now I'm going to end up with a product. I can't integrate a product yet. I can, you can't. You will learn a method to do a product using parts. But parts takes longer, especially with causes and sines in it. Parts will take longer. There is a much quicker solution using a trig identity. Sine squared is 1 minus cos squared.
Negative cos, do you then substitute?
I'm then going to use substitution. Take a little bit longer to get there. I'm going to go integral of, let's expand it, sine x, that's easy, minus cos squared x sine x. This one's easy, and this one I can use substitution. Let me write it. Integral of sine x minus integral of cos squared x sine x dx. These are the same, I'm just making it clear. This is the one I'm going to use substitution on. Let u equal cos x. Yes. Or you can use it as cos squared. Either way. Du is negative sine x dx. I have integral of cos squared x sine x dx. You know what? See this negative sign? We could include it if we wanted to. I'll put it here, right? This is the integral of u squared du dx dx. Or if you prefer, sine x dx with a negative sign, I can just write du. It's up to you which way you want to do that. So this bit is u cubed on 3, or what's u cubed? Cos cubed x. And therefore my original integral, we'll do this a bit. My original integral is, integral of sine x is negative cos x plus 1/3 cos cubed x plus constant. So we used a trig identity to get something we could use substitution on. expecting it to be a cube, it's not very clear. Cos cubed x, sine to the 10th x.
You split up the cos in the same way, but then
I'm going to, yes. Why though? I've got a cos and a sine in it. Ideally, I'd like to use substitution. So I can, because cos is a derivative of sine, or sine is a derivative of cos, doesn't matter. But because there's a bigger power on 10, this is my more complex expression. So I want to substitute u being sine x. And I'm just going to get a cos out of that. So I'm going to go, let u equal sine x. So du is cos x dx. So far so good. I'm going to get the integral of cos squared x sine to the 10th x is u to the 10th du. I've taken one of those causes out of the way. I'm left with a cos squared. But my u is a sine. Wait a minute. I can use a trig identity to turn this into a sine. This is the integral of 1 minus u squared u to the 10th du. Because u is sine x, cos squared is 1 minus sine squared. Expand the brackets, u to the 10th minus u to the 12th, which you can do. U to the 11th on 11 minus u to the 13th on 13 plus constant, and substitute back.
U to the 12th?
2 times 10?
20.
No, plus.
Plus. Why?
Because it's not u squared to the power of 10, it's u squared times u to the 10th.
Oh, yeah, yeah.
It's always the year 8 and 9 maths. Always. Sine of 11th x. You can write it on 11 or put a fraction out the front. Doesn't matter. 13th x plus constant.
oh well.
Yeah, let me show you two options here. There's actually three options. I'm doing it with odd powers, but the principle is going to apply. There are three different things I could do to work out this integral. One you already know. That's a derivative of that. So you can use substitution. Let u equal sine x. Du is cos x dx, so this is the integral of u du, which is half u squared sine squared x plus constant. That's one valid integral. Here's another. You have a trigonometric identity that has sine and cos, that has sine times cos.
Half 2a? I mean half sine.
Yes, in this case, yes, correct. So it's going to be half sine 2x. And I can do that. It's a quarter, negative a quarter cos 2x plus constant. You can probably convert these using the other identity. because I can turn a sine squared into a cos 2. And there's a third option which you haven't done yet. Is the integral of u dv, which is the integral of u, v minus v, integral of v du. We haven't done that yet, but that's parts. So there's yet another way to do it that we are going to get to. This way will take you longer. Parts works, reliable, takes a long time.